Today we are to the title of our chapter 2, and the title is scaling VLANs. Okay, and this is a CCNA routing and switching scaling network version 6 of Cisco course. Okay, so without much ado, let's begin. Now here in this chapter, we'll quickly go through the VTP and the extended VLANs and the DTP. The VTP is the VLAN Trochee protocol, while the DTP is known as the dynamic Trochee protocol. So we're going to go through the VLAN Trochee protocol and the dynamic Trochee protocol, and even the extended VLANs, okay, virtual local area network. So we're going to take a look at this. We'll look at the configurations of enhanced inter-switch connectivity technology. We'll compare the VTP version 1 and version 2, and we configure the VTP version 1 and version 2. We configure the extended VLAN, and we configure the dynamic Trochee protocols and troubleshoot multi. In section 2.2, we look at the troubleshoot of multi-VLAN issues, and then after in 2.3, we look at the artery switches. So without any delay, let's further look at the very first part, which is 2.1, the VTP, extended VLAN, and DTP. And we start with the VTP. Now, VTP, like we said earlier, it means VLAN Trochee protocol. Okay, virtual local area Trochee protocol. Now let's take a look at the overview. The VLAN Trochee protocol, which we call VTP, allows a network administrator every time in a network to manage the VLAN on a switch connected as a VTP server. So here, one of the switch will be connected as a VTP server, and this VTP server does the management to other client switches in the network, right? Now, another point to note is that the VTP server distributes and synchronizes all the VLAN information over the truck linked to the VTP enabled switches throughout the network, so throughout the switch network. So what this means is that the VTP server distributes all the information, the Trochee informations, the VLAN informations over the truck to the cleared VTP, so the cleared VTP. Okay, so from the VTP server to the VTP cleared. Is that okay? So that's what it does over the entire network. And let's take a look at the components and the compositions of the VTP. Okay, let's take a look at the VTP components. The first one is the VTP domain. Okay, the VTP domain consists of one or more interconnected switches. So when you're talking about the domain, you're talking about the switches connectivity and interrelatability. Okay, that's what you're looking at when you're talking about the domain. The switches that are arranged and how they be connected from one to other and also to the VLANs. Okay, then another very important component of the VTP to note is the VTP advertisement. Now the VTP, okay, before the VTP advertisement, let's also still look at the domain. The domain also, what is done is that all the switches in the domain share the VLAN configuration details using the VTP advertisement. So all the switches get within the domain get all the VLAN all the informations, the configuration details, okay, from the server, okay, to the client through advertisement. And advertisement, we're going to talk about it when we'll be talking about the other components that are used to broadcast this advertisement. Now, switches that are in different VTP domain do not exchange VTP messages. Okay, take note of that. Switches that are in different VTP domain do not exchange VTP messages. Now, a router or a layer 3 switch defines the boundary of each domain. So the moment a switch connect a domain, the switch and probably a router. Okay, we can say a router because you can have more than one switch in one domain. You can have 2, 3 switches in one domain, but the moment we have a router, you leave it that enclosure, that domain, and every other place that the packet is routed to or is broadcasted to, it's in another domain. So VTP only work within a domain. Okay, so anything that is not within that domain is out of reach for the VTP. Now let's talk about the VTP advertisement as fast as we can. Now we say each switch in the VTP domain sends a periodic global configuration advertisement. Yes, every switch in the VTP domain sends a global configuration advertisement from its own trunk port to multicast addresses or multi-layer addresses that are available. Okay, so it's going to send it multicast to multicast layer addresses that are available to it. So each switch is capable of doing this. Every switch in the VTP domain is capable of sending its own global configurations in form of advertisement. It's like, so advertisement here is like it's telling the other switches what it has and the data that it has, the information it has, the information it has, the information it has, that it has to, the traffic and everything that it has to send across. So it broadcasts what it has is like an announcement. So that's the advertisement. Every switch does this in the configuration. Is that okay? In the domain. Every switch within the domain, within the VTP domain, does this regularly. Okay. Now, the neighboring switches, they do receive the advertisement and update their VTPs and their VLAN configuration as necessary. So when this broadcast comes, every other switch check whatever, update themselves, whatever is being broadcasted, update themselves with regards to the VTPs and with regards to the VLAN configuration informations that have been broadcasted or that have been multicast, within the VTP domain. Now let's talk. Another component in the VTP studies is the mode, VTP mode. Now let's talk about the VTP mode. First, we've talked about the VTP domain. Second, we've talked about the VTP advertisement, and we say every switch in the domain does this advertisement kind of sort of. And then the third one is the VTP modes. Now a switch can be configured in three modes, in three different VTP modes. One, a switch can be configured as a server mode, can be put in a server mode. Two, a switch can be configured in the client mode. And the third one is that a switch can be configured as a transparent. Transparent is not active. Transparent is only used when we want to negotiate something, okay? When we want to advertise, okay? The transparent is only used, the mode, transparent mode for VTP domain or VTP configuration is only used when any switch want to advertise its content, its information, global information. So when a switch want to advertise its global informations, then the transparent mode become put into use. But the normal ones, the normal ones are the first two, which is the server mode of the VTP server and the VTP client. These are the normal ones that are used on daily basis and regularly. But the transparent mode is not used regularly. It's usually when advertisement is being broadcasted or multicasted. Okay, because in this case we're talking about multicast. Okay. Now, the fourth component in the VTP study is the VTP password. Now, VTP switches in the VTP domain can also be configured with a password. Okay, switches can be configured with a password. Okay, in VTP. Now, one thing to note is that the VTP advertisement will not be exchanged if the truck between the switches is inactive. If the truck is inactive, so the truck must be active. If the truck between VTP is inactive, then the advertisement will not be exchanged between one switch and another switch in the VTP domain, right? So if the truck is inactive or it has been misconfigured, then nothing is going to happen. So we must check the truck key, if the truck key is active or not. Now we move on because for the sake of time, we have to finish this lecture as fast as we can. Now let's talk about the VTP, still on the VTP concept and operations. Let's talk about the VTP modes furthermore. Now remember we said there are three modes: the VTP server, number one; number two, the VTP client; number three, the VTP transparent. Now we said the transparent is normally not too active except there is need for it, except we want to advertise. Okay, that's when the VTP transparent is put into use. Now the first one, which is the VTP server, let's talk about it a little bit. Let's take a look at what it means and how it carries out its operation. Now let's talk about the VTP servers. Advertise the VTP domain VLAN information to other VTP enabled switches in the same VTP domain. The server, VTP server, advertise the VTP domain VLAN information. Okay, every VLAN information the server gets, it has to advertise it to all the VTP server switches that are in the network, within the domain. Okay, so it advertises this information to other VTP enabled switches in the same VTP domain. Then the VTP server also stores the VLAN information for entire domain NVRAM. NVRAM simply means non-volatile random access memory. Okay, they save the server save all the VLAN information in the NVRAM, non-volatile random access memory. Okay, then another thing is that for the VTP server is that the switches configured in the VTP mode, the switches configured in the VTP mode are allowed to create. See, the switches in the configured in the VTP server mode. We're talking about the server now. The switches configured in the server mode, not just VTP. The modes are three, like we said. We have the server mode, the client mode, and the transparent mode. Now, any switch that is configured as a server mode, they are allowed to create. Okay, these servers are allowed to create. They are allowed to delete, and they are allowed to rename VLANs for the domain. So any VLAN, any virtual local area network within the domain, the server, the switch that is acting as the server is allowed to create whatever he wants to advertise or broadcast or whatever he wants to do. Is allowed to create, is allowed to delete. The server is allowed to delete any VLAN. The server is capable of deleting any VLAN from its configuration. The server is allowed to create within its domain. The server is allowed to rename VLANs for the domain. Okay, the server itself in its entirety is enabled or put in a form that is able to rename a VLAN for its own domain. Okay, so this is the server, the functionality, what it does, the meaning, what it does. Now let's go to the client. The VTP client functions the same, just the same way as the server, but just that you cannot create, you cannot change, you cannot delete VLANs on the VTP client. So you cannot create a VLAN, you cannot delete a VLAN, you cannot change a VLAN on the VTP client. You can only do that on the VTP server. Remember, VTP means the VLAN Trochee protocol. Okay, VLAN Trochee protocol is a protocol. Okay, now, so the client is same as the server, just that the only difference is that the server you can create, you can rename, you can delete, but in the client you cannot create, you cannot change, you cannot delete any VLAN on the VTP client. Okay, that's one. Another thing to note for the client, VTP client, is that VTP client only store the VLAN information for the entire domain while the switch is on. So the moment you switch the switch off, the switch goes off, then the VLAN loses, the VTP client loses everything. Okay, so it only stores the VLAN information as long as the switch is on. It only has them when the switch is on. The moment the switch is off, then it loses everything. Another thing to know about the VLAN client is that a switch reset deletes the VLAN information. Once you reset the switch, once you do a reset, every VLAN information is deleted from the switch client, the VTP client. Okay. Then another thing you need to know that you must configure the VTP client mode on a switch, only on the switch. Okay. You have to configure when you do it's only done on the switch. Okay. Now let's go to the VTP transparent, the third mode. The third mode, which is called the VTP transparent. VTP transparent switches do not participate in VTP except to forward VTP advertisement only. Any switch that is configured as VTP transparent do not participate in the VTP activity. The only thing it does is to forward VTP advertisement to VTP client and VTP servers. So the only thing the VTP transparent, any switch that is configured as a VTP transparent do not participate in the regular activities of the VTPs, especially the VLAN information, do not participate. The only job it does is to forward the advertisement to VTP client and VTP server. Now, VLANs that are created or renamed or deleted on the transparent switches are local only to that switch, only to the switch only. Okay. Now, to create an extended VLAN, a switch must be configured as a VTP transparent. So, if you want an extended VLAN, if you want to create an extended, we're going to talk about extended VLAN. Okay. So to create an extended VLAN, a switch must be configured as a VTP transparent switch when you're using the VTP version 1, whether you're using version 1 or VTP version 2. Is that okay? Now let's go to the next one. Still on the VTP mode, let's Let's analyze them based on certain questions. Let's differentiate them based on some questions. For example, the VTP questions, the first question we go to ask to, we will use these questions to check the VTP server, the VTP client, and the VTP transparent. Now, for example, one of the questions could be, what are the differences between the VTP server, VTP client, and VTP transparent? What are the differences? Now, one is that the VTP server manages the domain and VLAN configurations. Okay, the server manages the whole entire domain and also the VLAN configuration. And another job it does is that multiple VTP servers can be configured. You can do many VTP servers, okay, on your system. Okay, now that's on that. Then on the VTP client, update local VTP configuration only. You can only update it for client is only on the VTP local VTP configurations. You cannot, any other VTP from another domain cannot be updated within this domain. Okay. Now, another difference between the VTP client and VTP server is that VTP client switches cannot change the VLAN configuration. We already said this earlier on. Okay, the VTP client switches cannot change the VLAN configuration. The VTP server is able to change, to rename, to delete any configuration, any VLAN configuration, whereas that of the client cannot change or rename any VLAN configuration. Now let's look at in the case of VTP transparent. VTP transparent manages local VLAN configuration. Yes, because it broadcasts between the VTP client and VTP server. It broadcasts the VLAN information, right, between the VTP client and VTP server. Okay. Then another thing is that the VTP transparent is able to do is that the VLAN configurations are not shared with VTP network. The VLAN configurations, they are not shared because it's not participating, right? The VTP transparent is not participating, so the VLAN configuration are not shared with the VTP network. Now let's go to another question that we use to differentiate between these three. Now, does it respond to VTP advertisement? Does it respond to VTP advertisement? The server participates fully. The server responds to any VTP advertisement. The server does, right? The client also do. VTP client participate fully, respond to respond to the VTP advertisement. The client respond. But what of the transparent? Only forward VTP advertisement. It does not respond. His whole job is to forward. It's like a messenger. VTP transparent just forward the advertisement. VTP transparent does not participate fully. Okay, it's like a catalyst that speeds up the rate of reaction but does not get itself used up. So his job is simple. His job is he forwards the advertisement only, but it does not participate in what is going on within the VTP modes and domains and whatever is happening in the VTP class. So then another question is, the global VLAN configuration preserved on reset? Is the global VLAN configuration preserved on restart? For VTP server, yes. Global configuration are stored in the NVRAM, that's the non-volatile random access memory. So the VTP server stores the configurations on NVRAM. For client, no. Global configuration are stored only in RAM, random access memory only. For VTP transparent, no is the answer. Local VLAN configuration is only stored in NVRAM, only local VLAN configuration. Now, another question is, does it update other VTP enabled switches? For server, yes. For client, yes. But for VLAN, for transparent, no. Now, here is the advertisement. Let's quickly talk about the advertisement. VTP advertisement. 3 types of VTP advertisement. One is called the summary advertisement. Now, the The summary advertisement contains the VTP domain name and configuration revision number. Domain name, configuration revision number. This first switch advertises, okay, new VLAN is added, sent to switch 2 from switch 1. What are the things it contains? Contains the VTP domain name and the configuration revision number. The second type of the VTP advertisement is the advertisement request. Now here, response to the summary advertisement message when the summary advertisement contains a higher configuration revision number than the correct value. So once the summary advertisement is sent from one switch to another switch, then a VTP advertisement request is sent back from the receiving switch to the original switch. So the VTP advertisement request is sent back, okay, especially when the advertisement contains a higher configuration revision number that is way higher than the correct value. So when the revision number is higher than the correct value, then advertisement request is sent back. Now once that is received, then the subset advertisement is again sent. And the subset advertisement contains the VLAN information, including any changes. Contains the VLAN information, including any changes, especially the revision number. So it's sent back to the new switch. Okay. Now let's take a look at the versions. We talk about the domains, we talk about the mode, we talk about the advertisement, VTP advertisement. Now let's talk about the VTP versions. Now we say there are 3 versions: version 1, version 2, version 3. But version 3 is out of the scope of this course. Maybe version 3 you do at master's level. Okay, for your final year undergraduate, you're not going to be doing, you will not do version 3. Okay, version 3 we reserve for master studies. Okay, now we will take a look at version 1 and version 2. Now version 1, VTP version 1, first of all, let's look at the definitions. Look at the definitions and the functionality. Okay, version 1, we say default VTP modes on all switches. Every Cisco switch, even non-Cisco switch you buy, comes with version 1 by default. It comes with VTP version 1 by default. So every switch we purchase in the market comes with version 1 by default. And it supports normal range VLAN only. You know normal range, right? Normal range are VLAN 1, which is a default VLAN, VLAN 1, and then VLAN 1002, 1003, 1004, and 1005. There are 5 normal VLANs. So all these 5 normal VLANs are supported by version 1 by default. They're supported. Okay. Now let's go to version 2. VTP version 2 supports the normal range VLANs only, also support the normal range VLANs, and then support legacy token ring network. So with this you can create a token ring network with version 2, and also support advanced features including all recognized, also support advanced features including all recognized type length value. We call it the TLV, type length value. Okay, and then version dependent transparent mode, support version dependent transparent mode, support consistency check, and so on and so forth. So you can see version 2 support a lot of things. So not only support the normal range VLANs, it supports a lot of other things like the token ring network, support the advanced features like the length type length value, version dependent transparent mode, and consistency check. Now let's go to the default VTP configuration. Now let's talk about the configuration. How do we configure VTP in our switches? How do we configure VTP? Now we use the show VTP status command to display any VTP status, which include the following. Now here are the things that after we configured we see, or we normally configure on on a switch for a VTP operations and concept. One is the VTP version capable and running. So we can see the version that is capable and that is running in our switch. We can use a show VTP status to show this. We can use a show VTP status to show the domain name, to show the VTP running mode, to show the VTP trap generation, and device ID also, to show the configuration last modified, when last the configuration was modified, VTP operating mode also. In this case, the operating mode may be transparent. We may choose transparent, okay, so that we'll be able to advertise whenever we want to advertise from one switch to another switch using a multicast. Now, we also be able to show the maximum VLAN supported locally, and we also show the number of existing VLAN that is on the switch network, and we also show the configuration revision and the MD5 message digest 5, MD5 digest. So we can also show all of this. Now, how do we verify default VTP status? Now, if you want to verify anything that has been configured to see whether they are running in your network, you put the switch in the global configuration mode. How do we put this switch in the global configuration mode? We'll say switch 1 hashtag config terminal. So we configure the terminal of the switch 1 hashtag config terminal. So once we configure the terminal of the switch, then we succeeded in putting the switch in the global configuration mode. Now, have we done that? Once you put the switch in the global configuration mode, the next thing to do is to configure whatever status codes that we want to configure. Now, once we have done that, we finish the configuration. Now we want to show the status. So we say switch 1 hashtag show VTP status. Once we do that, it will show us the VTP version capable 1 to 3. These are the versions that the meaning is capable of running on version 1, version 2, version 3. VTP version running is telling you, okay, it's only version 1 that's running right now, but it's capable of 1, 2, or 3. It shows you the VTP domain names. It shows you the VTP pruning mode. Okay, pruning mode is disabled right now. VTP trap connection disabled also. The device ID gives you the device ID you're using, the switch device ID you're using, which is I think this is the MAC address. And then the configuration last modify shows you, and then it shows you the VTP operating mode, which is transparent, maximum VLAN supported 255. It shows you everything, display, even your MD digest gives you, then the number of existing VLAN. It tells you there are 12 VLAN in the system. So it gives you all this breakdown. Now let's go to VTP carvit. VTP carvit. Carvit, I think carvit takes care of 3 things, 3 or more things, but there are 3 very significant things that is taken care of in the carvit. One of it is the revision number. Okay, the VTP configuration revision number. Okay, it's something very important. The configuration revision number is stored in our non-volatile random access memory. So we need to know what's going on, where it's stored, how it's being used. Now, to reset the VTP configuration revision number to 0, we change the switch VTP domain to non-existent VTP domain, and then change the domain back to the original name. First, we change to non-existent, then we change it back to the original name. Then we'll be able to, when we do that, we are succeeding in changing or configuring the revision number to 0. Another thing we need to do, because not only this we have to do, another thing we need to do is to change the switch VTP mode to transparent and then back to previous VTP mode. So we change the domain to non-existent domain and then back to the original name, and then we change the transparent, the VTP mode to transparent, and then back to the original mode. And then when we do that, we'll be able to reset the revision number, configure the revision number to 0. Now, quickly, let's take a look at VTP configuration overview. The configuration overview, step to configuration. These are the steps to configure VTP in our system. Like I told you, first you have to put the switch in the global configuration mode by saying switch 1 hashtag config terminal. So switch one hashtag config terminal, put the switch in the global configuration mode. Once the switch is in the global configuration mode, then these are the following steps, or these are the other things we need to configure. Step one is to configure the VTP server. Okay, we have to configure the server. Step two is to configure the VTP domain name and password. After you configure the server, you have to configure the VTP domain name and domain password. Then step three is to configure the VTP client. You remember server, you've done server, then you configure the domain name and password. The next is to configure the VTP client. The next is to configure the VLANs. After the VTP client, then you configure the VLANs. You know the VLANs are running to the switch. They are your stations, your workstations that are connected to your switch. So you configure the VLANs on the VTP server. You configure the VLANs on the VTP. Then the last but not the least step is to verify the VTP clients have received the new VLAN information. You have to verify. Okay. Now we're going to run the following. This part is the first one. Okay. You can see this is your server. You can see VTP server. So this is the first we're going to configure. We configure the VTP server, then we configure the VTP domain. The domain is here, somewhere here, the truckee area. This is the domain. We configure the VTP domain name and password, the trucks, okay, the domain name and password. After that, after configuring the VTP domain name and password, this area, this region, the next is to configure the VTP client. Look at the VTP client, these switches. They are used as the VTP client. We configure the client. After configuring the VTP client, is to configure the VLAN on the server. These VLANs that are here, they are your workstations, your PCs. We have to configure them on the server as well. Okay, we configure the VLAN on the server, and then the last but not the least is to verify the VTP clients have received the new VLAN information that we've done. Now here are the configuration. We start with the first one, which is to configure the VTP server. Now to configure the VTP server, here are the following steps we go to take. There are the steps we go to use. We use the VTP mode server command to configure the switch as a VTP server. So you're going to use the mode server command to configure it. And then we confirm all the switches are configured with default configuration before issuing any command to avoid any problem with the configuration revision number. Okay. So after that, then we use the show VTP status to verify whether what we have done is in order. If it's in order, good, we are good to go. We move to the next step. If not, we fix this first step. You don't finish everything before you do the show command. Okay? When you configure the server, you do the VTP show VTP status. You do the show VTP. You show it and see whether what you have done is in order, and then before you move on. Then look at it. Look at what we do. We say switch one hashtag config terminal. This to put in the global configuration mode. Okay. Once you put it in the global configuration mode, then the next is to configure the server, the VTP server. You now say switch one config VTP mode server. VTP mode server. That's it. Then after you've done that, switch one show VTP status. You know, after you configure the server, you have to show to see if everything is running up and running. If they're not up and running, then you do again and fix your problem. And let's go to the next step two. Step two is to configure the VTP domain name and password. You know it's already domain name and password. It's already in the global configuration mode. So what you need to do is just to say switch one config hashtag VTP domain hashtag VTP domain. And then the next thing, you say switch one config hashtag VTP domain. You put the name CCNA. Okay, if you want the domain CCNA, you can call it CCNA. You know what you go to call your domain. You put a name. But in this case, we put it CCNA because we are doing CCNA Cisco program. Okay, for this final year. Okay, then the next one is the VTP name will be changed to the Cisco CCNA. Now the next one is switch one config hashtag VTP password. You have to, if you create the domain, you give it a name, the domain name by calling it a Cisco. Then you have to create password. So VTP switch one config hashtag VTP password Cisco 1234. You know what you want to call your password. Okay. For in this case, for the purpose of explanation of lecturing, we just call it Cisco 12345. So you can create any password, but make your password strong. Okay. Then after that, your job is done. Then what you need to do for this step two is a switch one show VTP password, and then it will display the VTP password. Step 3 is to configure the VTP client. After you finish the domain name and password, then you configure the client. Step 1, remember step 1 was to configure VTP server. Step 2 is to configure VTP domain name and password. Step 3 is to configure VTP clients. Okay, so what we do now, client is no longer switch 1. Remember switch 1 was what? Was for the server. Now client will be another switch, a different switch entirely. So we call it switch 2. So we say switch 2 config hashtag VTP mode client. So you first of all you declare it to be a client mode. Okay, this VTP will be a client mode. And then after that you say switch 2 config VTP domain CCNA. You put the name because you already created the domain, right? CCNA. And then after that, you say switch to config hashtag VTP password. You also put the same password. Then you say switch to config hashtag end. Okay? So these are the things you need to do in order to configure your VTP client. Then the first step is to configure your VLANs on the VTP server. Okay? To configure your VLAN. Now, use the VLAN number command to create the VLANs, okay? And then after you use the VLAN number command to create the VLAN, the next thing is to use the show VLAN brief to give you all the details, and show VLAN status to show you the status of the VTP VLANs, VTP. Now, this is what you do. Because you are configuring the VLAN on the VTP server, so we go to say switch 1. Remember the server is switch 1. So you're not going to say switch 2. So you say switch 1 config hashtag VLAN 10. So you state the VLAN, which type of VLAN. Is it VLAN 10, VLAN 20, VLAN 30? You mention the VLAN you are configuring. Switch 1 config hashtag VLAN 10. Switch 1 config VLAN hashtag name, you name it. Maybe sales department. This computer VLAN you are configuring is for sales department in the organization. So you say, you name it. So switch 1 config hashtag VLAN, hashtag switch 1 config VLAN, hashtag VLAN 20. Now, VLAN 10 was for sales department. Now, VLAN 20, you go to create another VLAN for another department. So we now move further. We say switch 1 config VLAN, hashtag, you name it, name marketing. This is marketing department. Then, that's VLAN 20. Now, we create another VLAN. We give it a number before we create the department. You say switch 1 config VLAN, hashtag VLAN 30. And then switch 1 config VLAN hashtag, you name the department, name accounting. Then you say switch 1 config VLAN hashtag end. Okay? So when you do this, you've configured all the VLANs and you connected them to what? Switch 1. Remember, switch 1 is your what? VTP server. Is the server. So you've created all the VLAN and you've connected them to your server. Is that okay? And if you show switch 1 hashtag show VLAN brief, it will display all the Ethernet, all the ports, the fast Ethernet 0/3, fast Ethernet 0/ all the Ethernet you're using, the port Ethernet, fast Ethernet 0/4, fast Ethernet 0/5, up to 0/24, and then Giga Ethernet. There is Giga Ethernet in your list. Then you see all the sales department, marketing department, accounting department. They are active, meaning you've configured them. They are running. Then the default VLAN, default VLAN 1 is the default VLAN. Then we also have VLAN 1002, 1003, 1004, 1005. They are part of the normal VLAN that runs with version 1. Okay, so you see all of them will be displayed. So then you say switch 1 hashtag show VTP status. To display all the VTP status that is ranging from 1 to 3, the version, but we are using version 1. You see the domain name, Cisco, CCNA, and then you see probably if you want the password, you say display password. It also show to you. Now we'll move on quickly. The last step is to verify the VTP client have received the new VLAN information. To do that is to just use what we call the show VLAN brief. Once you do that, you display all the information. Now we move on quickly for the sake of time. VLAN regis or catalyst, VLAN regis or catalyst switches. You know the two catalyst switches, right? We've talked about in chapter 1. Catalyst switch like 2960 and 3560 series. 2960 and 3560 series switches, they support over 4,000 VLANs. They can support over 4,000 VLANs, and they are called the catalyst switches. Now, normal range VLANs are numbered 1, 1, and 1 to 1005. But not just 1, 2, 3, 4, no. 1, then you start from 1002, 1003, 1004, 1005. Okay, these are okay from 1 to 1005. Normal range VLAN can support all of this. Yes, can support all of it from 1 to 1005. The extended range VLANs are numbered from 1006 to 4094. Extended range VLAN starts from 1006 to 4094. And these extended range VLANs, they are not stored in the VLAN that file, and the VTP does not learn from them. Okay, let's move on for the sake of time. Create a VLAN. How do we create a VLAN? To create a VLAN, just your switch 1 hashtag config terminal. You put it in the global configuration terminal. Switch 1 config hashtag VLAN 20. Okay, and then you name the VLAN. VLAN 20. Switch 1 config VLAN hashtag name. You know, in the previous case for business, for company, we are saying sales department, engineering department, manufacturing, mechanical department, any department. But for school, we can say, okay, this VLAN 20, we want to use it for students. VLAN 20 name student. Then switch 1 config VLAN hashtag end. So this is how we create a VLAN. Once this is done, we succeeded in creating a VLAN. Now, assigning ports to VLAN. How do we assign ports to VLAN? You just go to your global configuration terminal. You say switch 1 config terminal. Then switch 1 config hashtag VLAN 20. Switch 1 config VLAN hashtag name student. Switch 1 config VLAN hashtag end. Okay. So we will switch this to the port, that this one is supposed to be designated for. So access ports can belong to only one VLAN at a time. Okay, only one VLAN at a time. One access port to only one VLAN at a time. Only exemption is when an IP phone is connected to the port. That's when we have an exception. Okay, when we have an IP phone connected to a port. Then there are two VLANs associated with that port. So because of the IP phone and the network itself. Now, okay, so let's move on quickly for the sake of time. Now, verify VLAN information. How do we verify? These are the commands that we use to verify VLANs. We use the show VLAN, we use show interface, we use show VLAN name, we use show VLAN brief, we use show, you say switch 1 config before you write all the show VLAN brief, switch 1 for config, hashtag, show VLAN summary. All of these things, we display whatever we want. Okay, let's move on for the sake of time. Now we say, configuring extended VLAN. How do we configure extended VLAN? Okay, extended range VLANs are identified by a VLAN ID number from 1006 to 4094. Okay, this their ID number with which we know or we recognize an extended VLAN. So to configure them is switch 1 config hashtag VLAN mode transparent. We have to configure the VLAN in the transparent mode before we can add extended. Remember that. Then we say switch 1 config hashtag VLAN 2000. 2000 is a number between 1006 and 4094. So once you put it in 2000, meaning you are configuring an extended VLAN. So we say switch 1 config VLAN hashtag add. So we've configured an extended VLAN. If you want to see, you simply do switch 1 hashtag show VLAN brief. Once you do that, it will show you everything. This is a default VLAN. VLAN 1 is a default VLAN. 1002, 1003, 1004, 1000. Then you see VLAN 2000. You've just configured VLAN 2000. You see it's displayed. These are your Ethernet, the ports. These are your ports, okay? So you see everything is displayed, okay? So that's that. Now let's move on quickly for the sake of time. Now let's go to what we call the DTP. DTP is simply Dynamic Trunking Protocol. It's a Cisco proprietary protocol. It's a Cisco proprietary trunking protocol. And it's used for trunk negotiation. And every trunk negotiation is managed by the DTP, the Dynamic Trunk Protocol. So when the trunk want to negotiate, especially maybe from one network to another, if they want to negotiate, they use a DTP trunking. They use a DTP trunking protocol to negotiate. Okay. Now, automatically enable on catalyst 2960 and Catalyst 3560 series switches. These DTP, because they are Cisco proprietary protocol, so they are enabled in these Cisco switches. Okay, these DTP are enabled in all Cisco switches. Now, to enable Truckee from a Cisco switch to a device that do not support DTP, a device that do not support DTP means a device that is not manufactured by Cisco. So a device that is not manufactured by Cisco, most of them probably sometimes do not support DTP. So if you want to enable them to communicate, so what do? We say to enable Truckee from a Cisco switch to a device that does not support a DTP, we use what we call the switch port mode truck. Switch port mode truck and switch port non-negotiate. Switch port mode truck and switch port non-negotiate. So once we do this, then we're able to relate. We're able to relate any device that does not support DTP to be able to support a DTP. Is that okay? Now let's move on. We say negotiated interface mode, different trucking modes. Let's take a look at them. Switch port mode access is an interface. The interface becomes a non-truck interface. It becomes a non-truck interface. Then switch port mode dynamic auto, the interface becomes a truck if the neighboring interface is set to truck or is set to a desirable mode. Now, what about switch port mode dynamic desirable? The interface of this desirable becomes a truck if the neighboring interface is set to truck or desirable or dynamic auto mode. Now, what about switch port mode truck? The interface becomes a truck when if the neighboring interface is not a truck interface. Then what does switch port non-negotiate? This one prevents the interface from generating DTP frames. It prevents them from generating DTP frames. Is that okay? Now, to configure truck links statically whenever possible, we have to. Okay? Then we use the show DTP interface to verify DTPs as usual. Now we go to 2.2, troubleshoot. How to troubleshoot multi-VLAN issues. There are so many issues that may come up as a network administrator, a network engineer. There are so many interface problems that will come up. One of it is deleting VLANs. If you no longer want a VLAN, how do you delete VLANs? Let's assume switch 1 has VLAN 10, VLAN 20, VLAN 99 configured, and we want VLAN 99 is assigned to port fast Ethernet 0/18 through fast Ethernet 0/24, and we want to delete the VLAN 99. We want to delete. So deleting a VLAN from a switch that is in the VTP server mode removes the VLAN from all the switches in the VTP domain. Or if you delete any VLAN, the VLAN will be removed from all the switches in the VTP domain. Okay? Because it's the same server that is controlling all of them. So if you delete it, it's gone from all the domain, right? So it's no longer visible. So you cannot, but we cannot delete the default VLANs. Remember this. We cannot delete the default VLANs. The default VLANs includes VLAN 1, VLAN 1002, 1003, 1004, and 1005. Okay? We cannot delete these default VLANs. There are 5 default VLANs. We cannot delete them. So take note of that. You can delete any other VLANs that you configure yourself. Any VLAN, VLAN 99, VLAN 20, any VLAN you configure yourself, you can delete it from the VTP server. Is that okay? Or from the VTP domain. So how do we do that? How do we do this? We say switch 1 config, switch 1 hashtag config terminal. We put it in the global configuration mode. And then we say switch 1 config hashtag no VLAN 99. Just say no VLAN 99. Finish, you delete it. It's be gone. You will do show details now. We'll see show VLAN brief. When you type switch 1 hashtag show VLAN brief, we will see whether VLAN 99 will still be there. So you see, once you say no VLAN, switch 1 config hashtag no VLAN 99, it's gone. Then the next thing you do is switch 1 config hashtag exit. Then we want to see whether we still have it. We do switch 1 switch 1 hashtag show VLAN ID 99. VLAN ID 99 not found in the correct VLAN database. See, it's no more found in the database. Why? Because we already deleted it. Then, if you want to see more, you say switch 1 config show VLAN brief. When you do that, you see everything here. VLAN 1, which is the default one, there's VLAN 10, there's VLAN 20. Remember, there was VLAN 10, VLAN 20, VLAN 99 originally. There's VLAN 10, VLAN 20, the default VLAN up to 1005. Then there's no more VLAN 99. VLAN 99 is no more active. It's no more here. Okay, it's gone. We've deleted it. That's it for delete. That's one troubleshooting. If you want to delete any VLAN, let's go to another troubleshooting. How do we switch port issues? Switching port issues. When using the legacy routing model for VLAN routing, the switch ports connected to the router interfaces must be configured with the correct VLANs. If not, there will be switching port issues here and there. Okay, switch 1 fast Ethernet 0/4 is in the default VLAN. It's in the default VLAN. 0/4, this one is in the default VLAN and must be in access mode. It must be in access mode VLAN 10. Access mode VLAN 10 must be. Okay. Okay, let's move on. We say switch port, still on switch port issue. You see, now incorrect. Why? The default VLAN now you're using fast Ethernet 0/5. It was 0/4. So if you not following the correct interface fast Ethernet 0/5 on switch 1 is not configured as a truck. Since it's not configured as a truck, you have issues, and it's left in the default VLAN for the port. So you have issue. This will not be a correct. You have switch port issues and a lot of port issues arriving from your network and configurations. Now verify switch configuration. How do we verify? We just type what we call switch 1 hashtag show interface fast Ethernet 0/4 switch port. Then it will give us all the details that we want enabled. You can see it's enabled. The switch port is enabled, and so on and so forth. Okay. So the command to verify switch configuration is to type switch 1 hashtag show interfaces to show all your interfaces, and switch 1 config hashtag show running config to show you every running config. Now let's go to interface issues. Still on interface issue, I think we've dealt with this. Okay, interface issue, same problem with the port issues like we described. Okay, when enabling inter-VLAN routing on a router, one of the most common configuration error is to connect the physical router interface to a wrong switch port. The physical router to a wrong switch port. When you connect a physical router to a wrong switch port, you can see now this one to VLAN 10. Okay, now if you connect it to a wrong switch port, fast Ethernet 0/9. If you connect it to a wrong switch port, you can see fast Ethernet 0/9 is the default VLAN. Fast Ethernet 0/9 is the default VLAN. If we do otherwise, now here, look at it. Here, you're using fast Ethernet 0/5. So you have issues. So how do we verify? Verify routing configuration. These are the commands you show. You say use the show interfaces and show running config commands to show. For example, router 1 hashtag show interfaces. You display all the interfaces. But you know the first thing you to do, right, for routers. You do the same like we are doing for switches. Router 1 hashtag config terminal. Router 1 hashtag config terminal. Then we say router 1 hashtag show interfaces. Then to display all the interfaces and so on and so forth. Is that okay? Now let's move on quickly. Now this is incorrect IP address. Okay, errors with IP address and subnet mask. So if the IP address are entered wrongly, then we have issue also in our network. Now let's go to verify IP address and subnet mask configuration issues. What do we do? A common error is to incorrectly configure the IP address for a sub interface. Now we use the show run and show IP interface to verify the IP address running, and then we'll see if the IP are correct or not correct, and then we can correct them. Use the IP config to verify the address on the Windows PC, any Windows PC that you're using. Is that okay? Okay, so let's move on for the sake of time. Now let's take a look at troubleshoot VTP issues. Common problems with VTPs are incompatible VTP versions. Maybe one is version 1, the other one is version 2, or one is version 2 and version 3. These are some of the issues we always have. And another issue we have is the VTP password issues. Okay, the password issues. And then incorrect VTP domain name. You don't know the correct name and the password, and then you cannot log into the network. All switches set to client mode. You forgot to set a switch to the server mode. This is also a problem we have. Then incorrect configuration revision number. You put the wrong revision number in the configuration. Now let's take a look at the troubleshoot DTP issues. DTP is the truck mode mismatches is one of the issues. Another issue is the allowed VLANs on truck. Okay, another issue is allowed VLANs on truck. Another issue is the native VLAN mismatches. Okay, these are the three DTP issues we have. Now let's go to the last but not the least segment of this section of this class, which is 2.3, layer 3 switches. Now layer 3 switches, we say they can act as router, they can route and broadcast. Okay, multi-layer switches provide high packet processing rates using the hardware-based switches. Now we say the Catalyst multi-layer switches supports the following types of layer 3 switches: the routed port and the switch virtual interface. Okay, these three layer 3 switches can support all of this. Now all layer 3 Cisco Catalyst switches support routing protocols, but several models requires enhanced software in order to perform well for specific routing protocols. Is that okay? Okay, now let's move on quickly for the sake of time. We say inter-VLAN routing with switch virtual interfaces. Remember in the past, the early days of the switch network, when we had switching was very fast, but routing was very slow. Switching used to be very fast, routing is very slow. Now, therefore, layer 2 switches portions was extended as much as possible into the network. Nowadays, routing can be performed at a very wire speed. The routing is so fast, like as if there is no tomorrow. And it's performed at both the distribution and the core layers. The routing is done in both the distribution and the core layer. So distribution switches are configured as layer 3 switches or layer 3 gateway using the switch virtual interfaces. Distribution switches can now be configured as layer 3 gateway using switches, what we call the switch virtual interfaces, or what we call the routed ports. Routed ports are usually implemented between the distribution and the core layers. Is that okay? Now let's move on, still on the inter-VLAN routing with switch virtual interfaces. An SVI is a virtual interface that is configured within the multi-layer switch. It is configured within the multi-layer switch to provide the following: to provide a gateway for a VLAN so that the traffic can be routed into or out of that VLAN. So we use the SVI, the SVI, the switch virtual interface. We configure it at this level to provide a gateway for VLANs so that the traffic can either be routed into it or routed out of it. Another thing is to provide layer 3 IP connectivity to the switch. Okay, why we are putting SVI is to help to put layer 2 switches into layer 3 mode. Now, to support routing protocols and bridging configuration. Now, what are the advantages of having SVI? SVI means switch virtual interfaces. It's a virtual interface that you have to configure in order to put layer 2 switches or to put switches in layer 3 level. Okay, one advantage is faster than router on a stick. Faster than router on a stick. No need for external links from the switch to the router for routing. No need. You don't need the external link between the switch and the router because you are configuring a switch as a router to act like a router. Not limited for one link. Layer 2 Ethernet Ether channel can be used to get more bandwidth. Okay, so it's super ideal. Super ideal. Look at it here. Once you configure the SVI, this is the job of a router. Once you configure the SVI interface, you are able to convert a switch, a layer 2 switch, into a layer 3 device. Okay, now we move on, still on that. Now it's a VLAN routing and routed port. A routed port is a physical port that acts similarly to an interface on a router. It acts similarly to an interface on a router. Router ports are primarily configured between switches in the core and distribution layer of the network. Now, you use the no switch port interface command on the appropriate port to configure the router port. Is that okay? Now let's move on quickly. We say to troubleshoot layer 3 switches issues, we check the following. We check the VLANs, we check the SVI, we check the routing, we check the host. Once we check all of this, then we're able to troubleshoot any problem coming from all of this. Okay? So here is the summary of today's course. We've learned to configure enhanced inter-switch connectivity technology. We've also learned to troubleshoot issues with inter-VLAN routing environment, and we've implemented the VLAN routing using the layer 3 switches to forward data in a small and medium-sized business. Okay, so with this we've come to the end of our Cisco class. Okay, we pray that you understand and